Okay. Sorry? The point?
The previous one was the...
Never mind, leave that. Okay, good morning, ladies, gentlemen. So today, topic for TGIF. Today is Friday, 23rd January, Friday. So we are going to wrap up topic 4. Yeah, don't mind, come, please. Okay, I want to go through 3 examples. Yeah. Okay, don't mind, please. Settle down first. Today Friday, you're very excited. Okay, so can you please look at page 29, page 29 of your notes? Yeah. Okay, you're given a case, page 29. Alright, so you can, there's a diagram for you over there. Okay, but actually it's a, that one is, thank you.
Keep quiet.
Thank you, my class monitor. Okay, thank you. Thanks. Okay, moving on. So you have a question there. Okay, now sometimes your they give you certain memory chips, right? Okay, memory chips can come in different sizes. Okay, but sometimes we are given a certain requirement. Okay, then how do we meet that requirement? For example, if I say, okay, I have a computer system here, I need 1 terabyte of hard disk. Okay, but I don't have 1 terabyte hard disk now, but I got a few smaller sizes of the hard disk. Actually, I can combine them and then still work. That means I can maybe get 2 500 gig hard disks put together, and I still can give me the same 1 tera. Right? 1 tera means 2 500 gig hard disks together, for example. Okay, or in this case, for example, over here on page 29, lecture notes there. Okay, we have a requirement. I need to have something 16 by 8. Okay, what it means 16 by 8? What does 16 mean? What does 8 mean? Yes, correct. 8 will mean imply the data line. Okay, I would need something with 8 data lines. Okay, and I need 16 address location. Okay, that's what I mean. 16 means 16 address location. This is a very simple example. 16 address location. So you can see that this one refers to the address location. Alright. So, but you are given only conditions like this. For example, I'm given 16 times 4 RAM. It's just a memory. It doesn't matter what it is. It's just a memory. But I only have, this one comes with 4 data lines. You see? This one is 4 data lines. But this one you need 8, you see. The requirement is this. You need 8, but you are given this. How do you configure this to be this? But of course you can take multiples of this. Okay, so in this case, I can clearly see that I need 2 of these chips. It's not your potato chip, your memory chip. Okay. Okay, so I need 2 of these clearly because I need to double up this to give me its addressing. So you can see actually the solution is actually given to you, but let me explain it. You can see the solution actually they show you.
Okay, we don't need to draw, right?
No need to draw. Okay, you can read on page 30. On page 30, what it says is that you need to have the equivalent number of data lines, okay, to meet the requirement. Okay, so obviously I can actually double up. So double up means I need 2 of these. I can use 2. Okay, so you can see on page 30, the second point, second bullet point, right? To increase the word size, the data lines from 4 to 8, I need 2. Right? Very obvious. I need 2. Double up this so that I can meet the requirement. Okay, so then I can say that I can easily say because now it will be 4 lines and 4 lines for the data line. I can say that one of the RAM, let's say you read the solution there, right? It says that maybe I allocate, because it's up to you to design. Okay, this one you can have RAM 1 or RAM, I call it, or in the notes they call it RAM 0 and RAM 1, right? So your RAM 0 can store the 4 higher order bits. Then the other RAM 0 will store the 4 higher order bits. Then something like this. It means let's say your D7, right? D6, D5, D4. Right now. So this is one set, right? And of course you have the D3, D2. Yeah, correct. Okay, so it's up to you to allocate it. Okay, so you can see over here, it's very clear that the RAM 0 take care of this. If you look at the diagram, it's very clearly drawn. Can you have a look at the figure also?
Yes.
Yeah, so you can see that the diagram says that this one is handled by this particular memory chip with this identification number called RAM 0. This one is by this thing called RAM 1. You understand? Okay, but your address line is fixed. In this case, 16, right? That means there are 16 memory locations. 16 physical memory locations. 16. So that means if I were to draw a memory, this is a very simple case, right? Because I can have, what did they say there? A3, is it? Yeah, okay, let's say A3, A2, A1, A0. So there are 16 of this combination. Okay, from here to here. 16 combinations. It's very much like your digital logic, right? Because this one can represent this, right? All the way until this. Right? So it means 16 different combinations. Is that clear?
This one is all theory, right?
Calculation later, the memory one, they'll tell you from what to what. You need to calculate the address lines. Okay, that one will be on word example 2. You'll see shortly. Okay, so this one is the easiest case because you got nothing to do with the addressing line. So very clear cut, this one is simple. This one is case 1, very simple. You just cover 2, then it works already. Straight away connect all together. Okay, so it's half lah. That means half, and half is taken care. You slice this thing into half. Half taken care by the one of the RAM. The other one is another RAM. Okay. Yeah, your number of data here is still 8 bits here because of the 8 points. It's only the address.
So there's 2 RAM on memory chip, is it?
Sorry?
There's 2 RAM on
Two memory chip.
2 memory chip.
2 RAM. 2 RAM. Using 2 RAM.
Why call it RAM 0 and RAM 1?
Because it's 2 physical chip. 2 different physical chip. Memory chip. Okay?
So one memory chip is only 4 input.
Address.
4 address.
Correct.
And the B7, B5, B4
Remember there's data and address. Okay. Data and address. You must give him the address first. Then only you can write the data into the memory. You must have, very important is the address first. Address tell you is unique. Remember? No, unique. All addresses are unique.
So 2 to the power 4 give me 16 addresses. I have 4 data lines.
8 data lines. 8 months.
Teacher, you want to ask why RAM 0 has to be a higher than
Doesn't matter, it can be flip-flop, up to you. Depends on what you
It's
say.
how it's on the order you put, right?
Up to you. I can call it a RAM 1 also, if I want it a RAM 0. I call this RAM 3, RAM 4 also can one. It doesn't matter. Huh? No, the data, no, inside got 8 points. Remember, the data is here. This data is 8 bits. This data has 8 bits. Okay, symbolized by this.
So you separate it into
two memory chips, physically separated. Physically, but on a memory map you cannot see because to you is one unified map. Memory map. This is called a memory map. You see a memory map, it doesn't matter. But this is the no. That's not the standard. It's 8, 16, 32, 64 in that kind of order.
So I'll ask you, now you only 16 times 4. So the government say you want 16 times 8. So that means
you're given this.
So I use 2 chips for that?
Yes, 2 memory chips.
But if I use 2 memory chips, I have 32 addresses, right?
Huh? No, your address line is the same. 16.
16 times 16 is 32.
Times.
No, because we're using 2 memory chips. 1 memory chip has 16 addresses.
Yes.
2 memory chips has 32 addresses.
No, still 16. 1 memory chip 16, right? But you're doing a parallel circuit for the address line. Can you see it's parallel? Can you please look at page 29. Page 29. The figure itself, what they are trying to show you is that the address lines are parallel. You see it? You are using 4 lines, no doubt. What I'm saying is that you are using 4 physical lines to generate 16 combinations. I can explain again. You're using 4 physical address lines, right? But you know 4 is 2 to the power of 4, right? You can have 16 combinations. Do you see what I mean? So you use these 4 lines, but you can generate 16 different combinations. Okay? But this thing is connected in parallel. You see carefully, if you look at the figure, it's very clear. They actually connect in parallel. You see your figure. You see it?
Yes.
Oh? I can't draw here, I mean it's inside your note. So if the lines are connected in parallel.
The address.
Yeah, the address lines.
The data line.
Data lines are later they will combine into 8. 4 and 4 come out, they will merge to become 8, you see?
Or it means you're tapping with the same point, that's why you're parallel, is it?
Yes, correct. Which means that your address bus, in other words, right, address bus is 6, address bus has 4 lines. 4 physical lines. Okay, 4 physical lines, your data bus is 8 lines. See the figure? See page 29. Okay, so this is the key takeaway. Address line got 4, the data bus got 8 lines. Okay, data bus. 8 lines.
So normally we only bring them in parallel, like, won't bring them in series, right?
No. Never in series. This kind of thing cannot connect in series. Parallel. Okay, so that's case 1. Page 29. Quite a lot there to digest. In fact, page 29.